This is your brain on risk. This is Mind Over Money, the podcast where Kevin Cook exposes the psychology of investing.
Welcome back to Mind Over Money. I'm Kevin Cook, your field guide and storyteller for the fascinating arena of behavioral economics. In our last episode from October 17, we explored the powerful new computing technologies known as machine learning and deep learning. These AI genies were let out of the bottle by computer scientists and engineers who learned to harness semiconductors that were originally designed for advanced gaming graphics. What these researchers discovered was that the GPU chips, that stands for Graphical Processing Unit, made by NVIDIA and AMD, provided the parallel processing required to teach machines to go beyond replicating simple human intelligence tasks like filtering your email for junk, and to do things like win at extensive or extremely complicated games like the Chinese game Go or Texas Hold'em poker. With lots of data, both structured and messy, a computer can be trained to analyze language, images, faces, and behavior that would seem like it could be financial fraud. So that's why the banks, PayPal, etc., are investing heavily in AI technologies that can help them monitor fraud when there's just, millions of transactions going on every day. So, this is all about algorithms and neural networks that try to copy what the brain does. The cool thing about what these scientists get to do is, if you learn about the brain evolved over, tens of millions of years. And, there's a theory that our brain has its own stack of, reptilian base, and then a mammalian brain, and then our neocortex, and all these different parts and functions, and and somehow they create this symphony that we call consciousness, and your personality. But there's a lot of competing things going on too, and that's where our irrationality comes from, and it's based on chemicals too. So it's not just a neuron, a synapse, and a dendrite with electrical sparks communicating. There's 100 chemicals in our brain too. So computer scientists, want to model a neural network, but they get a cleaner presentation, so they can stack levels of data and problem solving in their algorithms, and even combine algorithms. So what they end up with is they're able to create some sort of serial training, and then advance to parallel learning and what they might call tuning and inference. So, they end up with a tool that can act as a filter, for massive amounts of data automatically, right? Because you can't hire 1,000 people to analyze all the data coming through when a computer can do the job. And, what can this accomplish? It does everything now, from tailoring an online shopping, entertainment, or research experience to driving your car, even detecting skin cancer or some sort of macular degeneration from diabetes. That's an incredible project that some healthcare companies have done with AI, where, the way that diabetes can affect your eyes early on is it's hard to detect, but it's also the critical time when a certain treatment can help. So early detection is huge for that. All right, so and what NVIDIA did was they created a platform. I'm going to talk later about a man named Andrew Ng, who is a chief scientist for Baidu, and he basically says that what NVIDIA did, Jensen Huang, I believe is his name, spelled Huang, if I'm pronouncing that right, Jensen Huang, the CEO of NVIDIA, was, that he took a gamble, 7-8 years ago, that his GPU chips could become a foundation for artificial intelligence, machine learning, deep learning, and that was a huge thing. And what he did was Jensen Huang built a platform with the acronym CUDA. CUDA stands for Compute Unified Device Architecture. And so that created a platform that a university or a corporation could then make deep learning applications, right? They couldn't just, they just didn't need to buy NVIDIA chips to do it, or AMD chips. They needed a structured framework, and that's what CUDA is. So with a platform like that, then you can play games of chance, and so I'm gonna review a little bit about poker, And, in just the few sentences I've, run off here so far, I greatly run the risk of oversimplifying all of this. The evolution of deep learning from machine learning. Again, I'm not a computer scientist, so I am definitely oversimplifying lots of things because there's all these nuances. There are many different paths that researchers at universities and corporations have taken using these technologies. And so any one of them might stand up and say, no, that's wrong, Mr. Cook. But I'm doing the best I can. And I'll share an exchange I had with one of the experts coming up. So the best way to talk about any of these paths or applications of the technology and learn from them is really on a case-by-case, problem-by-problem basis. So I'll do that in this episode by approaching several examples, including IBM's Watson, Google's DeepMind AlphaGo, which was in the news last week, and our main topic from last week, the team at the University of Alberta who solved Texas Hold'em poker with DeepStack. All right, so we'll do a little DeepStack redux here. What I love about the DeepStack ability to take on poker pros. First, remember I told you last week, 2 years ago, they solved limit hold'em, which is a much more defined problem because bet sizes are limited and raising is limited. So the variables were, in a field that they can control at 10 to the 14th power. But no limit hold'em became this monster problem at 10 to the 160th level of complexity where they had to really adapt. And so when you think about it that way, going from limit hold'em, one level of complexity, to no limit, which is several orders of magnitude more complicated, involves more data, more possibilities, more decision trees, that gives you an idea of what they've been able to accomplish. And one thing I didn't emphasize about the DeepStack poker player, basically the machine, which plays no limit hold'em and beat lots of pros, is that the reason it can run on a laptop is because it doesn't need to access a database of all possible decisions. And in no limit hold'em, there's too many anyway. It couldn't run through 10 to the 160th. And what I didn't emphasize is that it's only thinking about 3 actions ahead. So in a given hand, it's only thinking about that hand and a few moves ahead. And so, but I was so intrigued by when I read the article and talked about that paper from the University of Alberta that was published on Science Mag, is that the lead scientist, Michael Bowling, kept using the word intuition. And I thought, man, what does he mean by that? So I actually emailed him last week. And we exchanged a couple of emails. He finally got back to me, and he replied to me this morning, and I got one back off to him. So learned some really cool things from him. Remember, I talked about CFR, which stands for counterfactual regret. So they make these to play a game like poker. They make the machine play itself, and then play millions and millions of games. And it learns, counterfactual regret is about, hey, if I did something with a negative outcome, then it knows it doesn't want to do that again. If it gets a positive outcome, it marks that. So I emailed Michael Bowling, and we didn't talk about CFR. I just asked him some basic questions. I wanted to know, hey, what processors were you using? I wanted to confirm that the first project against limit hold'em in 2015 was using AMD processors. And that was true. And he said they were only CPUs then. And then for the 2017 project, where they conquered no limit hold'em, yes, they were using NVIDIA GTX 1080 chips. The GPU workhorses there. So then, I asked him, well, when you're talking about intuition, a computer using intuition, is that because it learns from its recorded experience and then assigns probabilities, sort of in a Bayesian fashion of, what has the highest chance of working here, that kind of thing. And he said it's a little bit like that. So, and I'll read one thing from Professor Bowling here. He says, Because poker involves inferring your opponent's cards, then yes, DeepStack is doing real-time Bayesian inference, although I wouldn't call this case a hard instance of the problem. It is also doing flexible real-time game theoretic reasoning in order to avoid revealing too much information about its own cards. So that's pretty cool. And that this latter thing, he says, is one of the bigger advances for the field. And I asked him specifically, is DeepStack playing the player too, like observing their betting behavior? And he says, no, they haven't. They've done some research on that, but the DeepStack that just beat the poker pros this year isn't doing that yet. So, they've got a lot of research on their plate, and expect some cool things to come out of the University of Alberta using the NVIDIA chips and what else they can accomplish there. So, we're going to talk about some more cool things today. I mentioned IBM. I mentioned Google's DeepMind AlphaGo program, and the big news there. And I should just say that there's always going to be this question: what is AI and what isn't it? And I think it helps to take a step back and remember that these scientists are solving like really task-based problems. They're not, even though it seems like, so they've taught a computer to think and solve the game of poker, but I mean, it doesn't mean that same program can be used to play another game. It doesn't have that intelligence doesn't carry over, or it's not going to drive a car, or diagnose an illness. So, it's important to see that even then, if you could connect all these things, then it would still require a massive computer to run it all. So, I should clarify something from Professor Bowling at the University of Alberta. So remember I said solved means that, what they did in 2015 with Limit Hold'em was that they, basically cracked the code. That's what I said. And that, in a statistically significant way that, was way beyond random. And then they, could essentially almost always win in that game. But in the no limit version, they don't use the word solved because there is a possibility that somebody could figure out how DeepStack plays and beat it, but they just haven't yet. And that's why it was able to take down some pros earlier this year. So through all of this, we're really just talking about different tasks that AI can do, machine learning, deep learning. And remember, AI, still we could poke fun at it. We could say artificial intelligence, what is that really? We're not replicating the human brain here. We're just doing things that look like we're teaching a computer to have intelligence and do some analysis, do some prediction, but very, focused on a specific task. So if you want to learn more about the DeepStack poker problem from the University of Alberta, go on sciencemag.org and just search for the 2015 paper. You can sign up for free, get the 2015 paper, read that one, and it'll be, a good start in that direction. Just for fun, this past week, I did something I've never done before. I played some games on my phone. I see people playing games on their phones all the time on the train, and I'd rather read a book or surf Twitter. But I downloaded a poker app and started playing other people, and I realized what I was really trying to accomplish was I wanted to just play a lot of hands, and because I could grab my son and try and get him to play poker with me, but that could take hours and hours, and I'd probably just lose money. This, what was neat about playing online in an app is that the hands move very fast. You're only given like 15 seconds, I think, to call, bet, or fold. And if you don't, then it folds for you. So I probably played well over 200 hands and got a lot of experience. And I think I learned that I am not going to become a poker pro. And it's fun, but it's the wild randomness I can't handle. So I'd rather play poker with the stock market. All right, coming up after a quick break, we're going to talk about Google's AlphaGo Zero program, which a deep learning program they just announced last week. It just amazing stuff happening there. The machine taught itself to beat all other Go programs in just 72 hours. I'll be back faster than you can spell counterfactual regret minimization. right, the big news last week in artificial intelligence deep learning land was another computer clobbering a game. And you may remember that last year, Google had a program called AlphaGo that beat the top Go player in the world. Go is, of course, the important Chinese strategy game, which is more complicated than chess and was actually a bigger problem to solve, almost as big as the poker challenge because of the complexity. And, you can't even run a computer wouldn't run a decision tree on it because it would just get so massively complex. So last year, AlphaGo beats the top Go player in the world. I believe he was a Korean. And just last week, they announced that they created that their latest version of AlphaGo called AlphaGo Zero. They did something a little different. They let it train itself. Probably gave it basic rules and let it train itself. And in 72 hours, it trained itself to a level of skill that it could beat the old machine hands down, like 100 times in a row. Let me just quickly read some from an article from October 18th from the BBC by Rory Seelan-Jones. The article is titled, Google DeepMind, AI Becomes More Alien. Oh, and I should say that DeepMind was actually a British company that Google bought. So, it was just a group of computer scientists and AI aficionados, and Google recognized their talent. And I don't know if I think that was before they conquered Go last year, bought the company. So now it's part of their AI. So let me just read from this article. Google's DeepMind says it has made another big advance in artificial intelligence by getting a machine to master the Chinese game of Go without help from human players. The AlphaGo program, devised by the tech giant's AI division, has already beaten two of the world's best players. It had started by learning from thousands of games played by humans. Okay, so that's key, is studying past games and then picking up the patterns. But the new AlphaGo Zero began with a blank Go board and no data apart from the rules, and then played itself. Within 72 hours, it was good enough to beat the original program by 100 games to 0. DeepMind's chief executive, Demis Hassabis, said the system could now have more general applications in scientific research. So, this was just last week they announced this. It's obviously a big breakthrough, and I think it is going, as it's just raising the buzz level here, I believe, for corporations, and that's really where I'm headed in today's discussion, is that corporations are going to be realizing more and more that they need to have some type of machine learning, deep learning, AI skill set, capabilities, just like 20 years ago or even 15 years ago, they realized they needed to have an internet web strategy. And I think it's the same kind of revolution here. What businesses succeed now without any type of web presence or strategy? Probably very few. This is going to be the same type of thing for, information management, because it's not just having big data management in the cloud. It's what are you doing with that data? How are you analyzing it and using it to make predictions about your business? So that's kind of where I'm headed today with this. And it appears that AlphaGo does also use CFR, counterfactual regret minimization, and some form of intuition. I believe I was, Googled that and was looking for, is this using what they call intuition? And I believe I found that somewhere. If anyone knows better, give me a shout and we'll talk about it. All right, last week I teased that I wanted to show you how AI is being applied to the realm of psychology. And I found an amazing thinker and researcher the week before. He's an Argentinian named Mariano Sigman. And he was trained as a physicist, but he's been studying the brain and consciousness in data-driven ways for 2 decades. So you should find his TED Talk. So if you can just search YouTube, TED Talk, Mariano, Sigman, Sigman. It's must see. Or, you could pick up his book, his 2015 book, which was just translated into English this year, is called The Secret Life of the Mind: How Your Brain Thinks, Feels, and Decides. But the TED Talk that I want to tell you about would be a great introduction to Mariano, because he begins talking about the language of introspection. And he starts out, what words do we use? How have we talked about our own thoughts and consciousness? And he concludes in the TED Talk about how he is applying big data and AI to the words we use. And what he's leading up to is that the words you use can predict your mental health. And you could apply this, a psychologist could apply this on a one-on-one basis, dealing with a patient. How does the person talk to themselves, and where might that lead them 6 months, a year, 5 years from now? Well, Sigman wants to do that with AI and crunch big data about the way people talk, the way they communicate, write letters, write emails. And maybe he's going for, some type of program that could predict any individual's mental health based on, the way they write and communicate. Or maybe he wants to do it with the whole culture. I don't know, but definitely worth looking up. All right. So I have a little bit of experience with studying the brain and where it might intersect with the advance of human knowledge, so to speak. So, remember when IBM's Watson won at Jeopardy? That was a pretty big deal. And then, we start seeing all the IBM Watson commercials, and I think they're hilarious. Whether it's with some professor or the dog training expert or famous tennis player or Bob Dylan. But an author I had read long before, read a couple of his books 10, 20 years ago, is a man named Shank. And let me, I think he's at Northwestern University. Let me see if I can find him here. And he took issue with IBM's Watson and what they were supposedly advertising. And I read this, or I found his rebuttal on LinkedIn. Let me see if I can find it right here, because I should have looked this up earlier, but I didn't have the link. So Roger Shank is a professor. I'm almost positive that he was at Northwestern. But he really went after IBM's Watson for the claims they were making. He thought they were fraudulent. Calling it AI, was silly enough, but other things. And when you think about it, it's like if you watch a Watson commercial, does anybody really believe that the computer is thinking and talking, as another person? That it understands. No, isn't it obvious even to say a teenager that no, they are just making it look like Watson is having a conversation? Now, obviously, what Watson achieved by winning at Jeopardy was language recognition, translation, and then taking complex assemblies of words, in whatever type of riddle format that Jeopardy would create, and deciphering what it might mean. But that's still a task-oriented skill that they gave it, to look at a phrase from Jeopardy and then decide that it could mean these 100 different things, and then pick the most likely candidate by running it through several filters. I don't think anybody believes that that's real human intelligence, but Roger Shank took big issue with it, and we'll revisit that theme. I'll see if I can find his LinkedIn post where he challenged them. I want to take our last 5 to 10 minutes here and share a lot of other cool news and resources, because so much of this is coming together. I found 2 tweets from government bodies on Twitter getting excited and or nervous about the threat of AI. So last week I ended on a positive note. I said, hey, AI is coming. Let's learn all we can. Otherwise it's going to seem like magic. I actually picked that up from an NVIDIA guy. Will Ramey was on the very first NVIDIA AI podcast. And he said, yeah, you can either learn about this stuff and have it be familiar and understand what AI is actually doing, what a deep learning program is doing at your bank or your store or your insurance company or in your car, or you can just think it's all magic, if you don't understand it. and then that borders on people being afraid of it too. I imagine a lot of people would be afraid of getting in a car, an autonomous car, and letting it drive for them. So let me share some of the things I saw this past week. This is from The Guardian. I'll just read the headline on there and the tease on the tweet. Artificial Intelligence Commission needs to predict impact on business. So apparently a business group has urged the government in the UK to launch a commission to assess consequences of AI on jobs and increasing productivity. Now, this is something I talked about earlier this year when I cited the Oxford Martin study that automation could wipe out 50% of jobs in the U.S., in the developed countries, and as much as 75% of jobs could be eliminated in emerging economies like India and China because of automation, which is fueled by AI. So it's funny, you think about wherever you've worked, whether it's in a corporation or government, and you hear about somebody saying, well, we need a committee to do a study to tell us what to do. And sometimes that works out okay. Usually it doesn't. And this is one that I just laughed right away that they think that, okay, they're going to assemble a commission to study the impact of AI and somehow be ahead of it. When this thing is moving so fast, there's no way, anybody's going to be ahead of it. Because companies and universities and governments are going to be adopting different sorts of deep learning AI applications and just running with them. And there's no telling, by the time you do a study to predict what could happen, I bet you it's already going to have happened. So I found that a little bit interesting. And in another podcast I did earlier this year, I talked about Yuval Noah Harari and his book, Homo Deus, which is, hey, the future of mankind is this technology is going to accelerate, and there's going to be, the super rich, super intelligent who augment themselves with AI and biotechnology, and everyone else. And that was sort of the scary dystopia that he painted. But, let's just say that's 100 years away. So I think we'll know a lot more, even without a government commission making predictions. I think every year that goes by, the average person will know more about what's coming, in the next few decades. Another great headline I saw was, this was actually from MIT, but they were talking about the Brits again, and they titled this blog post, "Keep Calm and Massively Increase Investment in Artificial Intelligence." And I'll just read a couple of paragraphs here. The UK government has just released a thoughtful report on the potential of AI, along with some jolly sensible recommendations for making the most of the profoundly important technology. The report, co-authored by the Department for Digital, Culture, Media, and Sport, and the Department for Business, Energy, and Industrial Strategy. Wow, they have longer commission names and departments over there than we do. Concludes that AI offers massive gains in efficiency and performance to most or all industry sectors, from drug discovery to logistics. Okay, so they figured that out. The technology can be integrated into existing processes, improving them, scaling them, and reducing their costs by making or suggesting more accurate decisions through better use of information. So that was a quote from the report. And this could add a whopping $814 billion to the UK economy by the year 2035. I'm going to say that's the low. If they think that, so it seems like they're underestimating what's possible here. I bet you AI adds more than that to the UK economy by 2035. It's going to add percentage points to some GDPs. I'll give you an example here. I'm reading from, I'm an investor in Alibaba, symbol BABA, because of their, key position in China's economy, like Amazon here. And Wells Fargo is just looking at what Baba is doing with the cloud and with AI. And, they've got a crucial bridge between audience, data science, and their supply chain. And let me just quote here. And as China is poised to be the leading country to benefit from the trend towards artificial intelligence, and in parentheses, they say China will see $7 trillion in 10 years from AI, according to PricewaterhouseCoopers. We see Alibaba as well positioned to extend its capability to a growing number of industries. We liken this to the modern-day Kanban, or Toyota's lean manufacturing style, but where neural, net-backed models allow for audiences to factor more meaningfully into the supply chain analysis as well. So that's how industry is applying it, right? Linking supply chains and logistics and just getting more efficiency out of the economy. I had the pleasure of watching a live webinar presentation with Peter Diamandis, the SpaceX guy, and Ray Kurzweil. Kurzweil is a futurist who now works for Google, and he's considered like the most accurate futurist of the past, 40 years or something, just because he's been so spot on with so many predictions. And Peter asked Kurzweil a question that was burning on my mind, like, okay, if we're getting all this incredible efficiency from computing and other technologies, the cloud, 3D printing, even biotechnology, why don't we see it in the productivity numbers that the government puts out? And Kurzweil's simple answer was because it's in both the numerator and the denominator. Now, I don't know if that's an oversimplification, but I think there's got to be something to that. We're measuring productivity the wrong way, in terms of labor, because we're just getting such fantastic benefits out of it, and the costs, the costs go down, but it's all part of some circular equation. And I mean, all you have to do is look around and just see the incredible efficiency in your home, in your car, in your workplace. The things that you can do. You hold a massive computer in your hand with your smartphone. All right, I got to wrap this up here, but I cannot leave without sharing this quote from Andrew Ng. His last name is spelled Ng. I believe he is Chinese, and he is a Stanford professor, chief scientist at Baidu. I believe he also worked for Google, and he was a founder of Coursera. And what he did is he created an AI course on Coursera that's free. You can find it on YouTube, I believe. But if you're interested in learning more about deep learning and AI, definitely look up his course. But he was on an NVIDIA AI podcast, and he says that AI is the new electricity. So here's this big simplification. What he means is that when you think about how electricity transformed civilization 100 years ago or so, 125 years ago, it changed industry, it changed business, it changed cities, it changed the way people live. It upended everything. But now we take it for granted. We don't even use the word electricity when we talk about lights or computers or cars or refrigeration. We just it's a utility that we just take for granted. He says that AI will become like that. It'll just become so much a part of everything that we do and touch and interact with on a daily basis that you won't even notice it's there. So, the more I read, the more convinced I am about how much control we have. I want to leave you with one more resource. I just found a new book at the library yesterday called Life 3.0, Being Human in the Age of Artificial Intelligence by Max Tegmark. And Max is a professor of physics at MIT and president of the Future of Life Institute. He's also the author of a book called Our Mathematical Universe. And this is quite a book, quite a treatise. It's 300 some odd pages, and he's just going through the, what is AI and what are the challenges that we face in using it, harnessing it, benefiting from it. And so for me, it really comes, down to education. One last resource I wanted to give you was the Time magazine article. There was a professor who wrote a piece where he's, basically saying the same thing that I've been saying. Hey, let's learn all we can, and advising, colleges and college students how to adapt in the world of AI. I'll try and have that link next week, but if you have a chance, Google it. I'm going to check my Twitter feed right now and see if I retweeted it. No, I can't find it, but I'll have it for you next week, because just the approach of what any kid is going to do. Hey, study mathematics, study systems, whatever, but know that any business or skill you have could be disrupted by some type of deep learning AI technology. All right, next week, we're going to focus on the impacts and implications of deep learning and AI for one industry in particular, and that's my industry, investing. All right, thanks for joining me. We'll talk to you next week.